We've talked about names and predicates, which are two of the subsentential components that PL allows us to retain, that SL doesn't. Now it's time to turn to the third one, quantifiers. There are two quantifiers in PL. There's the universal quantifier, which we represent using an upside down A, and the existential quantifier, which we represent using a backwards E. The universal quantifier translates roughly in English into for all. So the universal quantifier is going to be really useful when we want to translate sentences in English that contain words like every, all, everything, everyone, that kind of thing. The existential quantifier translates roughly into English as there is at least one or there exists some. I prefer to say there exists some just because I feel like it rolls off the tongue a little better, which I think will become apparent later. But notice that this is a little bit different from the typical usage of the word some in English. So if I say like, there's some juice boxes in the fridge or something, that implicates in English that there is more than one juice box in the fridge, right? I think some, I don't know. I would say in English it implicates that there are like at least 3 juice boxes in the fridge. But in logic, for that sentence to be true, there are some juice boxes in the fridge, it only needs to be the case that there is one juice box in the fridge. And that would make the sentence true. So the usage of the word some in logic is going to be a little different from the usage of the word some in English. Okay, so that's an introduction of the two quantifiers. I wanted to explain them a little more by talking a bit about Aristotle's logic. The reason why I want to talk about this a bit is because I think getting a grip on the 4 sentences that Aristotle found especially interesting really helps when trying to symbolize sentences in PL. So I think that this is really good practice. Okay, so Aristotle thought that there were 4 really interesting kinds of sentences that he called A sentences, E sentences, I sentences, and O sentences. And he arranged them in this kind of like square or rectangle because he thought that it captured interesting relations between all of them. So let's take each of them in turn and translate them into PL. So take the sentence, the A-type sentence, all A's are B's. How you would translate this into PL is you would write for all X, if X is an A, right? So where A is the predicate and X is the name that fills in the predicate. So X is an A, then X is a B. Okay, so for all X, if AX, then BX. Now let's consider E-type sentences, no A's or B's. You might expect this to be the opposite of all A's or B's, but actually it's not exactly the opposite. If it were the opposite, then we could just put a negation at the front, right? And then translate that over here. But actually how you symbolize no A's or B's is as follows. For all X, if X is an A, then it's not the case that X is a B. So that says everything in the world that is an A is not a B, or in other words, no A's are B's. That's different from saying it's not the case that all A's are B's. Okay, and we'll see why that is in a bit. So now let's move on to I sentences. So the I-type sentence is some A's are B's, and we represent that as follows. There exists some X such that X is an A and X is a B. And now consider the O-type sentence. Some A's are not B's. We represent that as follows. So there exists some X such that X is an A and it's not the case that X is a B. Okay, so those are the 4 types of sentences. And Aristotle represented them in this kind of like rectangle. It's really hard to draw on here. Okay, so he represents this kind of rectangle where we have A over here, E over here, I over here, and O over here. And he thought that the rectangle was helpful because there were some interesting relationships between the diagonals, and as well as the relationships across and down. Okay, and here's what they were. So Aristotle argued that each diagonal represents a contradiction. So remember I said that, it might seem like no A's are B's is the opposite of all A's are B's. But actually, the opposite of all A's are B's is some A's are not B's. So this sentence is truth functionally equivalent to the sentence, it is not the case that for all x, if ax, then bx. And you can manipulate that a bit to see why that's the case. Okay, so that's very interesting, right? The sentence some A's are not B's is the opposite of all A's are B's. Similarly, E is the opposite of I. So the opposite of no A's are B's is some A's are B's, right? And, when you think about it a bit, that makes sense, right? So the thought that there no apples, the opposite of the claim no apples are purple is the claim there is at least one purple apple. Okay, so that's sort of what Aristotle was getting at. Now, representing them in this way also gets at some really interesting relationships, not just in contradictions, but also in what can be true at the same time. So consider this second claim, A and E can be true together. So the sentence, all A's are B's, is compatible with the claim that no A's are B's. And that might be really puzzling. You might think, how is that possible? If all A's are B's, right? If all apples are purple, then how can all apples be not purple? I think that's it. Yeah. So that sounds really weird. And how that works is if nothing instantiates, if there are no A's, then both A and E are trivially true. So A and E can be true at the same time if there are no A's, right? So if there are no A's, then it's going to be trivially true that all A's are B's. And if there are no A's, it's also going to be trivially true that no A's are B's. Same relationship holds between I and O. It's these two claims are perfectly consistent. I think that's a bit easier to see, right? So the claim that some A's are B's is compatible with the claim that some A's are not B's, right? So some Michigan students are from New York is compatible with the claim that some Michigan students are from California. Okay, notice something else. The fourth point Aristotle made was that A does not entail I. So that means that the fact that all A's are B's, from the fact that all A's are B's, we cannot conclude that some A's are B's. And the reason for that is that all A's are B's might be true because there are no A's. The existential quantifier implies existence. So there has to be something that is an A and a B, right? Whereas the universal quantifier does not imply existence. So it can be the case that all A's are B's, even if there are no A's at all. In fact, the fact that there are no A's at all guarantees the fact that all A's are B's. Okay, so think about that for a bit. That's an important thing to note. The existential quantifier implies existence, the universal quantifier does not. Similarly, E does not entail O for exactly the same reason, right? So from the fact that no A's are B's, we cannot conclude the fact that some A's are not B's because there might not be any A's in the first place. And in order for this sentence to be true, there must be at least one thing that is an A so that it can also not be a B. Okay, again, universal quantifier implies existence. Existential quantifier implies existence. Universal quantifier does not. We'll start out by doing some simple symbolizations that involve quantifiers. Up here we have our symbolization keys. So we have our universe of discourse, which is, again, the set of things that we're talking about in this symbolization. And the universe of discourse in this case is the students in Philosophy 303, so students currently taking symbolic logic. Then we have the three predicates we're going to be using in these symbolizations. Okay, let's get started. So the first sentence we're asked to translate actually doesn't require any quantifiers in order to do. It's just a little warm-up practice. If Abe studies for the exam, so we want to take the predicate, X studies for the exam, and fill it in with the name in order to complete the sentence. So in this case, let's say A gets represented with a lowercase a. So if SA, then PA. Okay, whoops. Okay, now let's move on to the next sentence. Everyone will study for the exam. So here we're going to need the universal quantifier. And what to do is you write for all x, so for everything in the universe of discourse, for everything in the universe of discourse, so all the students in Phil 303, SX. So for all x, x studies for the exam. Okay, next sentence, some students won't study for the exam. So this is saying that there is at least one student who won't study for the exam. So we know we're going to need to use the existential quantifier. So there exists some x, there is at least one x, such that it is not the case that x will study for the exam. Okay, so notice that this is saying something different from it is not the case that there exists an x such that x sx. What this is saying is that no students will study for the exam. There doesn't exist any student such that the student will study for the exam. But what we want to say is that some students won't study for the exam. We don't know for sure whether any students will study for the exam, but we know that some students won't. And that's what this sentence represents. So again, you want the negation to go here and not at the beginning. Now moving on to this fourth question, which asks us to translate the sentence, if any student studies for the exam, Abe will. You might look at this sentence and see the word any and think that we're going to need the universal quantifier. So it might be tempting to robotically translate the sentence into, for all x, if x studies for the exam, then Abe will study for the exam. And that would be incorrect. And in order to see that, we need to sort of stop to think about what this sentence is saying. I think that, sentences of this kind often get said with a very particular tone. So you might say like, oh, that Abe, he is so diligent. He is such a good student. If anyone studies for the exam, Abe will. So what that's saying is that if even one student studies for the exam, right, like Abe would study, it would be Abe. So what this is saying, it's actually demanding the existential quantifier. It's saying that if there is some student who studies for the exam, then Abe will study for the exam. So that one student might be Abe, it might not be Abe, but all we know is that if anyone is studying for the exam, Abe will study for the exam. So be careful. Sometimes you might see words that tempt you toward one quantifier, but when you stop to think about what it's actually saying, it'll be clear that you actually need the other quantifier. Now moving on to the final symbolization of this first round, we want to translate the sentence, everyone will cheat off someone's test. Let's take a moment again to think about what this is saying. So what this is saying is that for everyone in the class, so for all x, there is going to be some person such that that person is going to cheat off that person's test. Okay, so everyone has someone whose test they're cheating off of. So here's how we would write that. For all x, there exists a y such that c x y. Okay, so this says, for all x, there exists a y such that x cheats off y's test. And that represents exactly what we wanted it to. Actually, now that I think about it, maybe we're not quite done. So the reason why that this might not be quite right is because we're not guaranteed yet that x and y aren't the same person. Right, so it could very well be that x and y are the same person, and that would be a problem because you can't cheat off your own test, right? So we want to specify that x and y are different people. So one way that I should have written the sentence in order to avoid ambiguity is to rephrase the sentence as everyone will cheat off someone else's test. And here's how we would symbolize that. So we would keep the beginning the same. For all x, there exists a y such that x cheats off y's test, and we're going to use the special identity predicate that we talked about in lecture, which allows us to specify among variables for names how what the identity relation between them is. So we want to say that X is not identical to Y. So this allows us to be clear that X and Y are different people. If this is confusing at all, I'm not going to go into the identity predicate too much because we talked about it a lot in lecture, but if you have any questions, please let me know about that. The identity predicate is just like a two-place predicate, such that you put one variable on this side and one variable on this side. If you want them to be the same, you use the identity sign, and if you don't want them to be the same, you use the non-identical sign. Okay, so once again, what this sentence says is that for all X, there exists a Y such that X cheats off Y's test and X and Y are different people. Okay, and that completes the first round of symbolizations. We're going to do a few more complicated symbolizations now. And the reason why it's more complicated is because we're expanding the universe of discourse to include all living people. So previously, the universe of discourse was just the students in Phil 303. But because we've expanded it to all living people, we have to be a little more precise in how we're translating things. So remember earlier up here, I talked about how these 4 types of sentences that Aristotle specified are really useful for helping us symbolize. And I hope that becomes clear now when we're symbolizing these more complex sentences. Okay, so let's start with the first one. Every student in Phil 303 will study for the exam. Because the universe of discourse is now all living people, we can't just say that everyone in the universe of discourse will study for the exam, like we did up here. Instead, we need to be clear that we're narrowing the universe of discourse down so that we're only talking about the students in Phil 303. So I'm looking at this sentence and it looks to me a lot like the A type of sentence that Aristotle wrote about. So a sentence like all A's are B's. So I suspect that this is going to take the form for all X, if AX, then BX. And since I have that suspicion, I'm going to translate this sentence as follows. So I'm going to write all blank are blank, and I'm going to fill it out in English, and then I'm going to change the all to a for all sign, and change the R to an if then sign, and then translate these bits of English into PL. Okay, so I hope this makes clear a little bit why I think that Aristotle's method is really helpful for symbolization. Sorry, I'm saying that a lot, but I do think that this is a really helpful technique. Okay, so let's give this a shot. Clean it up a bit. Okay, so here's how we take this sentence and put it in this form. All students in Phil 303 are such that they study for the exam. Study for exam. So earlier I said that, sometimes you use this method, you're not going to end up with a grammatical sentence. And this is exactly what I mean. All students in Phil 303 are study for the exam is not a grammatical sentence. But you can kind of see how this is representing the same sentence as this one. Okay, and now that we have that, we can just, translate this into the A-type format that Aristotle mentioned. And here's how you do that. So for all X, if X is a student in Phil 303, then X studies for the exam. This is the translation of all students in Phil 303 will study for the exam, or every student in Phil 303 will study for the exam. Okay, so that's the first translation down. Let's go to number 2. Some students in Phil 303 will not study for the exam. This looks a lot to me like an O-type sentence that Aristotle talked about. So some A's are not B's, which has the form, there exists an X such that AX and not BX. So now that I know that that's the format it's going to take, I'm going to write some blanks are not blanks. Okay, and here's how I'm going to fill that out. Some students in Phil 303 are not study for the exam. Again, not a grammatical sentence, but you can see how manipulating this sentence we're translating into this format will make it really easy to get the translation we want. So here's how we do that. Some students in Phil 303, so there exists an X such that X is a student in Phil 303, so LX, and it is not the case that S studies for the exam. Okay, I'm going to erase all this so that we can get a clear look at the sentence. So what the sentence says is that there is some X in the universe of discourse such that X is a student in logic and X doesn't study for the exam. And that's exactly what we wanted. On to question 3 now. We want to translate the sentence. Every student in Phil 303 will cheat off another Phil 303. On to question 3 now. We want to translate the sentence. Every student in Phil 303 will cheat off another Phil 303 student's test. Again, this looks like an A-type sentence to me, so it looks like a sentence of the form, all A's are B's, where the A's in the sentence are the every student in Phil 303, and the B's are, they're going to cheat off someone else's test. Okay, so we want to, again, create our little schema. So all blank are blank. The first blank is going to be all students in Phil 303. And now we want to think a little carefully about how we're going to fill in the consequent. So we don't want to write just such that there is another student in Phil 303 that they're going to cheat off of. And the reason why that is because you look at what would go in the consequent. So we'll cheat off another Phil 303 student's test. And you're not told exactly who this other Phil 303 student is. All you know is that they're a student in Phil 303 who isn't the same as the student referenced in the antecedent. So that's a clue that this is going to be another quantified sentence. So here's how I would write it. So all students in Phil 303 are such that there is some other student in Phil 303, and the first student will cheat off their test. So take a second to think about why this is a good way of framing what's being set up here. Okay, so we know that there's going to be a universal quantifier at the beginning, and there's also going to be an existential quantifier somewhere in the consequent. So let's give this a shot. So for all X, if X is a student in Phil 303, so LX, then, right now we're at the R, so then there is some other student. So let's say there exists a Y such that, well, first we have to specify that Y is a student in Phil 303. So Y is a student in Phil 303, LY, right? So Y is a student in logic, and the first student will cheat off their test. So we want to go C, X will cheat off of Y's test. And we're not quite done yet because we need to specify that this is some other student, right? So it's not the case that X is cheating off their own test. They're peeking over at someone else's test. So we need to use that identity predicate again, and we want to say, and X is not Y. Okay, so this is the proper symbolization of the sentence once we, of course, do the parentheses correctly. I didn't do the parentheses correctly in here, but that's okay as long as there's no ambiguity. As I said before, in predicate logic, we're being a little more loosey-goosey with parentheses, and that's fine. Okay, so this is the correct symbolization of sentence 3. Let's give sentence 4 a shot. If 1, let's say Phil 303, student cheats off another's test, then either both will pass or both will fail. I'm not going to use the same Aristotelian method as I did up there, but I urge you to do so if you find it helpful. For the sake of time, I'm just going to give the translation, but I hope you take the time to think about why this is a good translation for the sentence. So we want to specify that there are there are sort of two players in this sentence, right? There's the cheater and the person who is being cheated on. The person who is helping the cheater, not really helping, but the person whose test the cheater is looking at or peeking off of, something like that. So there are two players in the game, and those two players could be anyone in the universe of discourse. So that suggests the following, that we're going to want to translate this as follows. For all x and for all y, let's say that x is a student in Phil 303 and y is a student in Phil 303, and x cheats off y's test. Whoops. So x cheats off y's test, and we also want to specify that x and y are not the same person. Okay, so let's take a moment to think about why this is the correct antecedent. For anything in the universe of discourse, right, we're going to specify that x and y are those two things in the universe of discourse are both students in Phil 303, and x cheats off y's test, and x is not the same thing as y. So that is saying if one Phil 303 student cheats off another's test. So that's what that is saying. Now we move on to the consequent. Then either both x and y will pass or both x and y will fail. So that part's pretty straightforward. We want to say it's either going to be the case that px and py, or not px and not py. Okay. And then let me see, where do the parentheses go? I think that's right. Okay, so again, I didn't do the parentheses totally correctly, but in predicate logic, we're a lot more loosey-goosey about that. Okay, so what this says is that for any two things in the universe of discourse, if those two things are students in Phil 303, and one of them cheats off the other's test, then either both of them will pass or both of them will fail. Okay, so that completes that symbolization. There's one symbolization left for us to do for practice, and that's the following sentence. For everyone who takes Phil 303, there are 3 other people who don't take it. Okay, so this looks very much like an A-type sentence for me. All A's are B's. I'll let you do that sort of practice if you want to. But here's a good translation of this sentence. So for all x, if x takes Phil 303, so x is a logic student, so if Lx, then now we want to say there are 3 other people who don't take it. So we want to posit the existence of 3 other people who don't take Phil 303, and we also want to be clear that these 3 people are different, right? So here's how we're going to do that. So for all x, if x is a student in Phil 303, then there exists a y and there exists a z, and now we're out of variables, so we'll go with, and there exists a w. Okay, so there are those 3 people such that it is not the case that that y takes logic, and it is not the case that z takes logic, and it is not the case that w takes logic. And now we want to get clear that these 3 people are not the same. So we have to say that y is not z, z is not w, and y is not w. And those should not be commas, those should be ampersands. Okay, so obviously, again, the parentheses here are not done correctly, but I don't think that there is much ambiguity here since all the symbols here are ampersands. It should be okay. There aren't different ways that you could interpret this sentence. Okay, so this is saying that for all X, if X is a student who takes Phil 303, then there are 3 other people, Y, Z, and W, such that all 3 of them, such that they're all different people, and that none of them take Phil 303. Okay, so that's the correct translation for that sentence. I urge you to sort of slow down, take some time to like practice translating that yourself and to see why this is a correct translation of the sentence.